Today, we're going to be looking at creating our own tools in ArcGIS Pro that communicate with a Python script and undertake various computations. In particular, we'll be looking at introducing external web APIs or cloud-based services through their APIs that are exposed to Python. And you should have set up your Python environments for ArcGIS Pro and for PyScripter by viewing the section that says Start Here. So if you don't start where it says Start Here, go back and review that information and do everything that it asks you to do. Otherwise, you won't be able to complete the examples within this lecture or the exercise. So what is a script tool? A script tool is like any other tool in ArcGIS Pro. So here, for example, is a average nearest neighbor tool. And a script tool has a little like scroll beside it. So anything with a scroll beside the name in the toolbox tells you that that tool is written in Python. And it's therefore a script tool. And there are dozens upon dozens of script tools that come already with ArcGIS Pro that are written in Python in the toolbox. And most of those you could even export and modify yourself if you had to do something specific with them. So a script tool are everywhere in our toolbox. The advantages of a script tool are that the dialog box includes built-in validation of inputs. So on a ArcGIS tool, you can only input certain things. For example, inputs, if we go back here, like a feature class, well, it won't let you put a raster there. So no raster would be allowed to be put there if it asks for a feature class. So that's called validation of the inputs. The tool is integrated and accessible for geoprocessing workflows, including Model Builder and the Python window in ArcGIS Pro. So when you build a script tool, you can call that tool just like you would any other tool in our toolbox and use it within another script if you wanted to, or as a component in a Model Builder model. The environment settings are passed down from ArcMap, global settings. So you don't necessarily have to have special environment settings within your script because they can be controlled automatically by the ArcGIS Pro global environment settings. When you write a script tool, you can write messages to the results window when the tool is running so you can see what's happening. If it's running well, you can have debug messages printed out, etc. You can also provide documentation for tools, and sharing of tools is very easy when you have a script tool. All you need to do is upload the script into the toolbox tool and then share the tool box itself just by zipping it up and sending it to somebody, and then they have access to that tool and the script as well that goes inside of that tool. So let's look at creating a toolbox. So we'll start by here, for example, I have a Lecture 8 folder or Module 8 folder, you can call it whatever you want. And in there, I created a subfolder called My Scripts. And in My Scripts folder, I right-click and I say New, right here. And then I choose Toolbox to make a new toolbox. Pretty straightforward. And then I can name that toolbox anything I want. I just called it My Toolbox, and it will automatically have a .tbx extension. To create the script tool, I right-click on the toolbox, I choose New, and then Script. And that will open up the script dialog. So the new script dialog looks like this. It asks for a few things. It has on the left-hand side items general, parameters, and validation. In the general item, name, this is the Python tool name. For example, if this tool is going to be a tool that lists layers, then I might call this tool list capital layers, or something like list current layers, for example. You want to choose something here that's not going to conflict. So some name that does not conflict with existing Python ArcPy functions or tools. So there's already a method there, for example. We know there's a method on the map object in the mapping module to list layers. It's called list layers. So maybe that's not the best name, but that's not going to be confused with that method in any case. Now that name, again, is the name that you would use in Python if you were to use this tool as part of another script in Python. That name must be just like this, no special characters at all, no spaces in the name or anything like that. Then the label right here, the label is what we will see inside of ArcGIS Pro's toolbox. This can be more descriptive and can contain spaces. So this label I just wrote here, create a list of layers. And we always choose store tool with relative path. And that's very important. So if I did this and I click OK, the name is there, the label is there, and store relative path names. After clicking OK, then I see it in my toolbox, just like you see here. Create a list of layers, and that's a tool in a custom toolbox. So let's just call it custom toolbox. You can make toolboxes anywhere and have whatever you want in them. Then we must create a blank Python script and give it a name. For example, in PyScripter, I open PyScripter up and I save a blank script as list layers. I just call it list layers py, and I store it in the my scripts folder where the toolbox is. So in other words, you create a blank script, give it a name that's descriptive of maybe what it does or how it corresponds to the tool you're building, and save it in the same folder as your toolbox that you just created resides. Now that we have our Python script saved in the same folder as the toolbox, and we called it, or I called it anyway, layer list or list layers.py, then I right click back on my tool, I go to properties, and then I go back into my tool properties dialog right here. Then I'm going to use the little folder button on the right-hand side of script file input to choose that Python file. So I open that up, I choose my list layers py, and again, right now it's an empty script that is open still in PyScripter, and I'm just linking it here, and I click OK, and then it says it's in my lecture 8 my scripts folder, list layers.py. Next, we have to define the parameters that our tool will take in and then operate on in the script. So we now go from general to parameters right here. And these are the titles of the input boxes, as well as defining what type of things can be put in the boxes on a standard tool in ArcGIS Pro. So we click on the parameters option, and our script right now is going to take a single parameter only because it simply lists layers in a workspace. So for the label, I say choose a workspace. Like so, and then you type that in. The name you just leave it the way it is. That's the Python function parameter name. It just creates it from the label. Next, critically important is the data type column, and the data type for this workspace should be a workspace. So you click on this and it will open up the parameter data type dialog. You click on the down arrow and you choose what type of thing is allowed to go in there when somebody chooses something for that input. And we want workspace right here. So a workspace, that's what the tool will accept. So that's part of the, again, the validation of the parameters. Next, we want to choose a default value for the workspace. So we scroll over to the right of the same parameters where we just typed in, where the label and everything is there. And we find the environment column and we say, okay, from in the environment, current workspace. And that will, by default, fill in the workspace parameter with the current workspace in ArcGIS Pro, in case you don't want to choose one. Maybe you just want it for the current workspace, a quick list of, let's say, layers, feature classes, or something like that. And then you click OK. Now we go back to PyScripter. And PyScripter and Arc Pro are open at the same time. And now we're going to fill in stuff for our script. And we'll just do some simple things to start, such as sending a message back to ArcGIS Pro. So we have to now learn how to transfer the parameters from our script, because if you open your script now and double click on it, open it up, it will look like this. You'll have a different, this will be different, of course. So you'll have a different workspace than I do. And that's okay. So it'll be a different workspace. So it says choose a workspace, and that's it. Now we have to say, okay, how do we get this from the tool over to the Python script over here? Now, to understand how to do that, we have to understand that as we define parameters, each parameter has an index location on the tool itself. This is the first parameter. So this is the first parameter here. And it has an index equal to 0. Because remember, everything in Python for lists or whatever, indexes always start at 0. So the first parameter here is script input index 0. And if we had another box down here, then that would be number 1. If we had another box down here, that would be number 2. So we have to know which parameter is at which location and the index value of that parameter on the tool interface first. Then in our script, we add this line here. To get the parameter from the geoprocessing script tool, to take its value and have it inserted into our Python script as a variable, we say arcpy.getParameter as text, and then the index of that parameter. And here I give a descriptive name to the variable, in that this is a workspace. And so I called this the in_ws for input workspace. And I say that's equal to arcpy.getParameter as text 0. And of course, that's after I have my standard import of arcpy. Then I'll use a new method called addMessage you haven't seen yet. I say arcpy.addMessage, and I just say add the message of the input workspace. So it just goes right there. Now, addMessage is the way we can print things to the message window of the script when it runs. In our script now, we have our import arcpy. Then we get our input parameter from the script tool through arcpy.getParameter is text, and then the index, which is 0, since it's the only thing input on our tool, and it's the first thing at the same time. And then add message, just to send back the workspace to the messages window of the tool. Then you click save to update the script, go back to ArcGIS Pro and run the tool. When I do so, I have a workspace, and you can choose whatever workspace has layers in it, or whatever workspace you want. Click run, and then I click view details, and I go to the messages section and expand it, and it says right here, workspace, colon, and there's the workspace. That's what I asked to be printed by the ArcPy add message workspace. And this is just to show you so that you understand how we can communicate between the script and the tool to get parameters from the script, or parameters, I should say, from the tool to the script to work with, by what we call echoing that parameter back in this case. To create the toolbox for the first script, I'll go into my Lecture 8 folder, which I have just on my C drive, and I've created a new project in there called Module 8. And I'm going to go to the My Scripts folder, which is empty right now. I'm going to right click on that and say New Toolbox. And I'll call it My New Toolbox, or just My Toolbox, for example. You can call it whatever you want. And it's renaming it. Then I'll right click on my new toolbox and I'll say New Script. And up comes the new script dialog. The name for the new script, I'm just going to call it List Layers. And again, that's the Python name. So if I was to use this tool in a Python script, then I would refer to it by that name here. That name can't be or cannot contain spaces or special characters. The label, however, can. So I'll say the label here is create a list of layers, like so. Then I'm just going to click OK, just to see that it's created, and it has been created. And if I double click on it, it just says the name of it, and it looks like a geoprocessing tool, and it says no parameters, because I have not yet set any parameters for this particular tool. So I'll just close the tool for now. Then I'm going to right click and go back to properties here for that tool. So I right click properties. Now I have to specify a script file for that. So I'm going to go over to, not there, here, to PyScripter, like so. And in PyScripter, I have just a blank module open, which I'm going to save as, so I'll say File Save. And I'm going to call this file listlayers.py. I'm going to save it here in my scripts. So it's important that I save this particular script in the same folder that I have my toolbox. I won't see my toolbox here, obviously, because it's not something that is recognized by PyScripter. So I'll just call it list layers. So, and I'll click save. Then I'll go back to ArcGIS Pro. Now I want to link that script to this particular tool. And to do so in script file, I just go over to the right here to the folder. I click open. I'm going to go to my C, Lecture 8. There we go. C Lecture 8. And then in my scripts, that's where I saved it. And I might have to hit my F5 button to refresh that so I can see it. There it is, listlayers.py. So I didn't see it initially because I had not refreshed my catalog view. So I hit my F5 button if I didn't see it, and there it is. That refreshes this folder. And I click OK. And then it says, script file is C lecture 8, my scripts list layers.py. So now we have a script file linked to a tool. Next, we have to specify the parameters for our tool. So tool parameters, I'll just click OK on this one. Tool parameters are things you see in your toolbox. So if I go to analysis here, and I go to tools, and I just choose anything like calculate field, all of these things, input table, field name, expression type, code block, those are all called tool parameters. And we need to specify for what our tool does, its tool parameters. And we'll just do a simple parameter to start. So I'll go back now to create a list of layers, and I'll right click and say properties. And we'll have a simple parameter to start with, just to make sure that the link between our script and this tool is working properly. And I'll give the label, I'll say input or choose a workspace. And when I type in the label, choose a workspace, that's what you see atop the input box for a tool parameter. The name is made from that, and that's the Python parameter name. So probably don't put, yeah, there we go. Don't put the colons on there necessarily. So choose a workspace, that's fine. You don't have to change the name for the Python thing at all. And then the next important thing is the data type. Well, I'm looking for a workspace. So the data type should be a workspace. So I click on string, that's default. And then in the dropdown, I'm going to scroll all the way down to W for workspace. Right there, there's workspace. So that's that internal validation of using a tool, in that only workspaces will be allowed to be entered into that parameter, like so. Then the type is required. There's also optional if your tool doesn't need it to run, and derived, which we'll see later. So required will be always there, or derived. For our inputs are required, data type, and then the direction is input or output. And this is an input, so it says input. Then I click OK. Now, if I double click and open up my tool, I see a parameter there. It says choose a workspace, and I could click open, and I could go and choose a workspace wherever that is. And there I go. I've chosen a workspace. If I were to click run right now, I'll just get an error and say view details failed, because there's nothing in the script to do anything with. So I'll close my tool for now. Then I'll go back to my script. And in my script, I'm going to put my imports, import ArcGIS. And then I'll also import, or I don't need to import anything else, just import ArcGIS. And then I'll say in _WS for input workspace equals ArcGIS.getParameters as text. And then index 0. Because our tool has one parameter called workspace. It's the first parameter in the tool. It's lists of parameters because it's at the top, and that's index 0. And so whatever is in that input box is going to be stored in this script variable called in_workspace, WS. Now I'm just going to echo this back using arcpy.addMessage. So arcpy.addMessage will add a message, a text message. Well, not a text message like on your phone, but a message that's a string to the messages part of the running tool. And we'll see that in a second. So I'll say just arcpy add message and I'll echo back. That means just send back the input workspace to see if it works. So this will tell me that my script is linked and it works well because I get the parameter from the tool, store it here, and then I write it back to the tool message section when the tool runs. And maybe I'll write something maybe more fancy in here. I'll say quotes, your workspace is called, or is, oh, just is, that squiggly braces end quote dot format in WS, like so. So that will add that message, so we'll know it's our message. Then it's important that I click save to save that script. If I don't click save, and then I go back to Arc Pro and run my script with a workspace, it'll say failed again because I forgot to update the file. So going back here to Arc Pro, I'll double click on create a list of layers. I'll open this up and just choose a workspace, whatever comes up first. There's probably nothing in any of these ones. Let me just go to folders here, find something else. Go to my temp. Go down to the Ottawa COVID, for example. It doesn't matter what you choose. It's just going to be echoed back anyway. Now I'll click run. And it says completed well. And it's in this results dialog under messages right there. So let me just view details again. Under messages, it'll say your workspace is, and this is what I chose. So the arcpy.add message prints things to here. And that's particularly useful because you can, if your script is doing, let's say, looping over things or, and stuff like that, you could set a message back every time it iterates over something just to watch its progress if you wanted to. So that's a basic idea of how scripts work. So I'll close it for now. And this is supposed to be something that lists layers. Let's add the rest of our script so that we can create a script which will list all of the feature classes in a workspace, such as a geodatabase. So add this script here to the script you have in PyScripter. Just replace it if you want. You can copy and paste it. Now, as we see here, we import normal imports, but I also import OS. And that means operating system. And that's so that I can later on use this little term here called os.sep. os.sep means the operating system separator. Why? Because geodatabases, right, have a root of the geodatabase can contain feature classes and rasters, but most feature classes are organized within feature data sets, which are like a folder inside of a geodatabase. And so when we choose a geodatabase workspace, we need to be able to iterate over the data sets that might be in there as well to list those particular feature classes. So we start off here, imports, we get our parameter, which is the workspace right there as text. Next, critically, we now set the environment workspace to the input workspace. And we need to do that because remember, the ArcPy list functions only work in the current workspace. So if our workspace is a geodatabase and we say list feature classes, it will list the feature classes only in that environment workspace. And then we have to change that from from the geodatabase to data sets, feature data sets that would be inside the geodatabase as well. So the first thing we do is we just say in the root of the geodatabase, which is just the workspace, list feature classes, and then we add message feature class. And that prints out any root level feature classes in the geodatabase to the message window. Then we list data sets. So those are feature data sets within the geodatabase. Then if the list is not empty, because not all geodatabases have to contain feature data sets. So when we listed it, we could have an empty list. And if the list is not empty, then for each feature data set in the list of data sets, right here, right? So for each data set in the list of feature data sets, we switch to a new environmental workspace, which is the input workspace geodatabase plus the proper separator, / or / for the system, plus the data set name, such as, for example, Ottawa GDB / data, the feature data set. Then we just list feature classes again, because now this list feature classes will be for this workspace here. And we add the message for each feature class. Then we repeat for if there's a second feature data set, change the workspace to that, list feature classes, add the to the message printouts of each feature class name. So once that's in the tool called list layers, like so, you can see it here, then we run it, and choosing a particular geodatabase just from module 6 data as an example here, the Ottawa GDB, which has a couple feature data sets in it, then it lists them all out. So we can see all of them across all the feature data sets quickly, rather than having to go to catalog, expand and look, and stuff like that. So it's a handy little tool sometimes if you're just looking for certain things, or just want to explore what feature classes are in a series of different workspaces. So there's nothing here you haven't done before. This is all stuff you should know. And I'm going to make it a little bit, I don't need this message here anymore. I'm going to want to list layers, and this is something I want to do. So to do the list layers in a workspace, I have to import ArcPy. I'll also import OS. That's the operating system. Just so I can use the OS SEP, and you can see it's listed in there. OS SEP is for, or a most common path name separator for the operating system that we're on. So OS, import OS. Then I'll also import my environments. Since I want to use the ArcPy list functions, they only list whatever the environment workspace is set as. So I'll say here from ArcPy, import env. Then I have my parameter, my in workspace, and I'll set my environment workspace to that. So I'll say env.workspace equals in workspace, like so. Then I want to list my feature classes. So a workspace like a geodatabase, if I go back to ArcPy, and I just pick a geodatabase, let's say on temp here, where there's tons of them. Let's go down here, let's say like Ottawa. So this is a typical type of workspace, the geodatabase. Geodatabases, however, contain feature data sets like data or Ottawa data, which themselves contain layers, feature classes, like so. Moreover, in the root geodatabase, so that's at the root level of the geodatabase, we can see there's even 3 different things in here, feature classes. So a list feature classes tool should just iterate through all these, listing the feature classes that it finds. So keeping that in mind, I'm going to first list everything at the root level. So I'll say, okay, for feature class in ArcPy.list feature classes, print, or not print, but ArcPy.add message FC. So that's the feature class name. Next, I want to list any data sets and then iterate over all the data sets listing those feature classes. So I have to get a list of feature data sets like Ottawa and data or whatever, the sub feature classes that are in the geodatabase, the feature data sets, I should say, that contain feature classes. So here, I'll say F feature data sets equals ArcPy.list this data sets like so. So it lists all the data sets. Then, not every geodatabase will have feature data sets, but if it does, then I want to iterate over the feature data sets and listing everything in there. So I'll say if feature data sets, so that if feature data sets, if it's not empty. So if this list is not empty, this is what this is saying here. So if feature data sets is not empty, then let's go ahead and iterate over the feature data set. So I'll say for data set in feature data sets, like so. Next, I have to switch the workspace. So I have to say env.workspace equals in workspace plus, this is where the os.sep is used, separator plus data set, because that's the name of the feature data set. And that's how geodatabases are comprised. So env.workspace equals that. Then I'm going to add a message. I'll say in workspace, I'll say add arcpy.add message. Quotes, listing feature, listing FCs in squiggly brace dot format. And then I'll say here env.workspace. So now I have switched the workspace for each data set. Now, for data set, or maybe we should, we're already going through the data set. So we have the workspace. Now we're in the data set. So I'm going to list feature classes in there. So I'll say for feature class in arcpy.list feature classes again. I'll say arcpy.add message and just the feature class name, FC, like so. So that should work. So I'm going to save it. Then I'll go back to Arc Pro. And I'll run my tool. I got to find where it is now. There it is. And I'll choose, I'll go back to the full temp there and choose that geodatabase that has a whole bunch of stuff in it. The Ottawa one, I think it is. Like so. And then I'll click run. And I'll view details while it's running and messages. And there they are. That's the list. So we can see we have in the root geodatabase, neighborhood, centroids, gardens, polygon. Then it says listing feature classes in ctemp Ottawa GDB /data. That feature data set, and that has truck routes and neighborhoods. Listing feature classes in the Ottawa GDB Ottawa data feature data set, and has all those ones. So it works well. So now we have a complete script that works well for listing things in various workspaces. I can choose anything, run it, and I can then view the details, messages, and that's where I'll see the list. So that particular one, had a bunch in there too. So that's a complete tool now. If you wanted to share your toolbox with somebody, you can also go right-click on the properties here for create a list of layers, go back to the General tab, and if you click Import Script, then when you send just the toolbox to somebody, it will work as a regular tool. So the script becomes part of the tool. So if I click there, now it's embedded. If I click off of it, it shows where it was originally. Now it's embedded as part of that tool. And I could share just this toolbox with somebody and they would have no problem running that same without the script file itself, the Python file. So it makes a standalone script tool. Now, what if there are multiple parameters? So here's a script that takes in a layer from a data frame in ArcMap. So we can also have multiple parameters set on our script tool and have multiple parameters sent to a script. So here's another script. And in this particular script, what happens is we specify a feature class, a particular feature class. Then we specify the name of the output feature class, like so, and a workspace where that output feature class is going to go, like so. So we have inputs and outputs being specified here. So FC in is an input layer, FC out is an output layer, and out path is another output place where the output layer will be saved. So this is a script that would run in a standalone function inside of PyScripter, for example, because we have what are called hard-coded variables, like so. Hard-coded because they're actually written in. So this script will continuously produce the same results until the input feature class is changed, the output feature class is changed, or the workspace is changed. That means hard coding. Now, these can become script parameters. So then they're no longer hard coded. They're variables that depend on whatever a person chooses on their script. So this one starts by, we get the ArcGIS project, get the current map, and as long as a map is open, so notice here we're using active map for the first time, and that means a map must be open. So a map must be open. If it's not, that's checked here. So it says if my map right here is not none. So in other words, is my map something? If my map is something, that means I have an active map. Then I can list the layers in that map. So I get my layer, my list layers, and I use a wildcard, which is one of the inputs, the name of that feature class I'm looking for. Then I create a new feature class using ArcPy management, create feature class, just the geoprocessing tool, with the out path, which is again one of the parameters right there. And then the name of the output is again that second parameter right there. And the type that I want to be created, which is a point. So I'm creating a new point feature class. I'm going to populate that using an insert cursor. So I open an insert cursor on that new feature class with the shape at, so the geometry only. Then I open a search cursor on the input feature class right there. Again, getting the geometry. For example, of the neighborhood polygon. So each polygon geometry as a cursor. So cursor refers to the input layer, and in cursor is the insert cursor. for the new layer that's been created called new FC. So I go over each geometry, and then for each geometry in the cursor, I say input, or the insert cursor right here, insert row, the geometry dot centroid, which is a point. That's why I created a point feature class, since centroids are points. So again, that's like that, and the center might be right there. That would be the centroid. So it basically goes over each polygon, in this case in the neighborhoods, and gets the centroid, inserting the centroid as a point feature in the output layer. Then I have to remember to delete that insert cursor. If I don't delete the insert cursor, nothing will have been inserted. It'll have a blank new feature layer. So I delete the in cursor, and that then commits all of the changes. And of course, if there was no map open or anything, then I would want to print out saying error that you must have a map open to use this tool. So this script then creates a series of centroid points from each geometry in the input layer. And it has 1, 2, 3 inputs. Then I put that script inside of PyScripter, and I save it as poly to centroid.py. Once I have that saved, I'm going to have to create a tool to go along with that new script. So I create a new tool, and in the same toolbox as before, and I give the name geom to centroid. And again, that's the Python name. And then the label is create centroid layer from features right here. Then I open up and link the poly to centroid to the script file. So just like the previous example, except we have a different names for things and a different script. And that script is now linked to a new script tool. Then the parameters. So we have 3 input parameters: index 0 for the first one, 1 for the second one, and 2 for the third one. So if you recall, we have an input feature layer called FC_in. Then we have an output geodatabase called FC or outpath. The output geodatabase is outpath. That's the script name, I should say. And then we have an output feature class name, and that's just called FC_out in the script right now. Now, very important in here is how we set these up, in that the input feature layer, that's what it says on the tool. Data type is feature layer. For output geodatabase is a workspace. And then output feature class is a feature layer. Now, output feature class also must be specified as an output, not an input. So that's going to be an output variable, since it's something produced in the script itself. And then, of course, for the geodatabase, don't forget to scroll over to the right, environments, and set it as current workspace, so it gets that default value. So there's a geodatabase there ready to accept the output. Then we have to go back to PyScripter and edit our script and put these for the hard-coded variables. The FC_in gets parameter 0 right here, so the input feature layer. Then the output path gets the output geodatabase. That's the second thing, or index 1 in the tool. Then the output feature class is the third thing. And so that's index 2. And so we replace our hard-coded lines with that, 3 lines, as you see right here. So you go back and edit the script, put those in, and save the script. And now the script tool will be ready to run. So why I'm showing you this is that generally to create a tool, often you will hard code things first so you can interactively debug much easier any issues you have with your script in PyScripter by itself. So when they were hard coded, I could have ran that in PyScripter only. And once it works in PyScripter, then I know that I'm ready to go and specify the input parameters for a tool. And then I replace my hard-coded values that were here, like neighborhoods, a path for that one, a name for that one. I replace them with the input parameters from the tool that I just created, since it's already linked to this script. Then I can run it. So create centroid layer from features. And I specify here my input will be boundary. So this is the script tool. There's the default output geodatabase. And then the name of the output. And I click run, and voila, we have centroid layer, a point layer being added, to our default geodatabase right here. It won't show up automatically yet on the map. So I had to go into my geodatabase right here through catalog view and then drag in my boundary geom to centroid layer. And that's what it looks like. To make our output layer automatically show up on the currently open map in ArcGIS Pro, we have to add or do 2 more things. We have to add 1 more line to our script and 1 more parameter to our tool itself. So I right click on our tool and I go to properties and then into parameters again, right here. Then I just have a very last one called output. And I named it that. You can name it anything you want. But the important thing is that it's a feature layer, the data type, and you specify the type now as derived. So that means it's something that is derived from the script, created by the script itself. And then you click OK on the tool. Then we add this as the last line of our script. We say ArcPy set parameter as text. Which parameter? The 4th. So index 3 right here. And what do we want to set? The new feature class, new FC. So doing those 2 things, then when we run our tool again, and you can see where I put it here, the last line of the script, just FYI, that I'm talking about is right after deleting the input cursor, not after the else and print. So you only want to set parameter as text with a new feature class if a new feature class was made inside that if block, when it's true that a map is available. So it goes right after del input cursor. So that's the last line. The other stuff is just an else statement. So we put it there in the script, and then when we run our tool, the results will automatically be put into the map that we're working with. And it's a set versus get parameter as text. And that only works when the parameter is output and not input and derived. Let's add another script to our toolbox. So I'll right click on the toolbox and say new script. And this script will be a script that converts any geometry layer to centroids. There's already a tool that does that, but we'll show how we can do it anyway, just to illustrate. So I'll call this geom to centroids. That's the Python name. And then the label, I'll call that create Centroid layer from features. And it doesn't have a script file yet. And I can keep this open this time. So I'll just show how to keep it open. I'll go over here to, this particular Python. And I'll say new script, get rid of the stuff in there. And I'll save the script. I'll go file, save as. And in the same folder here, I'll call this geom to Centroid. And I'll save it. Then I'll just scoot over back to ArcGIS Pro and I'll connect that script file. Notice it doesn't list it in my scripts right away, so I have to hit my F5 to refresh that. There we go. We have to try it a couple times. And there's geom to Centroids. I'll click OK. So now I have my script linked. Next, I want to work on the parameters for the script. So what would a script like this need as parameters? Well, it would have to have an input of a feature class, an output workspace, and an output file name for the new Centroids. So I'll click on parameters. Label, input, feature layer. Type will be feature layer. So I'll click on that. And then here, feature layer. Click OK. It'll be required and it will be input. Easy enough. Then I'll have output workspace. That'll be a workspace. So I'll go down to the bottom workspace and choose it there. A workspace required and input. And also, I want to get a default value for that workspace. So I'll scroll over to the right to environment. And in environment, I'll say get that value from the current workspace right here. That way, whatever the workspace is set in ArcGIS Pro, it'll show up there as a default location. Then I have to have the name for an output. So I'll say output feature layer. And this will be a feature layer. Like so. And you might be wondering, why not feature class? Well, if it's defined as feature layer, then we can drag and drop things onto our tool. If it's feature class, we have to open it, use an open button and scroll to where the feature class is. So it's easier as feature layer. They do the same thing in the end. It's just tool-wise, feature layer is better to use. So that data type is feature layer. Type is required, but this time that's going to be an output. So I'm specifying that as output as the direction. Then I'm going to click OK. So in my scripts now, I have the create centroid from layer features. And if I double click on it, it has 3 parameters. So those 3 parameters that we see here are 0 index, 1 index, 2 index. So there's 3, and indexes start at 0, and they're in the order of which they are on the tool. So to get references to each of these in our Python script, we're going to say get parameter as text 0 for the feature layer input, get parameter as text 1 for the workspace, get parameter as text 2 for the output feature layer name. So I'll go back to my PyScripter now. So I'm going to start with some imports. I'll say import ArcPy. And then from ArcPy, did I spell that right? Yeah, from ArcPy, .mp import all. So I'm going to do some of the mapping module, and then env, of course, from ArcPy import env. So we'll need the environment settings. And I'm also going to put env.overwrite output equals true. And that's so I could run my tool multiple times with the same output data set if I want to, and it'll just overwrite it without asking or saying anything. Generally, for your own tools, put that, but for tools you might send to somebody, just don't put that in, because that's something they can set themselves in the geoprocessing options. So now I need my inputs. So the first input we know is going to be the input feature class. So I'll just call that FCN. And that'll be arcpy.getParameter as text 0. And then the out path or workspace is arcpy.getParameter as text 1. And the third thing was the output FC out for output feature class equals arcpy.getParameter as text. And that will be the third thing, index 2. So now I have my inputs to the script coming from my tool. Next, I want to make sure that the name of the feature class here that is specified by the user is a proper name for whatever they chose as the output workspace. So for example, if it's a geodatabase output and they put spaces in the name, well, we want to make sure that those spaces are changed for underscores so that they can actually be put into an output geodatabase versus a regular folder, for example, as a shapefile or something. So I'm going to use my validate table name. So I'll say FC out, again, just overwriting that, recycling that variable, equals arcpy.validate, validate table name, and that'll be FC out. So that just makes sure that FC out now is a valid name for the workspace. Next, I'm going to get the current document. So I'll say curdoc equals ArcGIS project, and that'll be current, because this is always running in ArcGIS Pro as a tool. So we can use current, and I can get a map. I can say, okay, my map equals curdoc.activeMap. So this is one instance where we can use active map, since we're running this as a tool in ArcGIS Pro. And as long as that tool has a map that's open in ArcGIS Pro, the tool should be able to run. And it will get the active map that the person is looking at the time. So we have that. Now, before I do anything else, such as creating new feature classes and creating centroids, I'm going to make sure that the map is something. So I'll say, if my map is not none, then go ahead and do stuff. First, I'm going to get the input layer reference. So I'll say my layer equals my map dot list layers, and then FC in. And 0. Remember, list layers gives back a list, and I just want the wildcard is just one feature class that I'm looking for in that map, since that's where it would come from. And I would get the first thing there. So my layer is the first layer, or the layer that the person chose as the input. And it's in the map that they have open. Next, I'll have to create a new feature class to hold the centroids. So I'll say new FC equals arcpy.management. I could have imported management, I suppose. Dot create feature class, like so. And then in here, I'll have my out path, the workspace, then the name, and then the type, point. Remember, it's going to hold centroids. Then I'll open an insert cursor on that. So I'll say in cursor for insert cursor equals arcpy.da.insert cursor. And with my new feature class, new FC, all I want is the geometry. So shape at. Then I'm going to iterate over my input feature class right here that we have. And iterating over that, I will get the geometry, get the centroid, and store it in the new feature class. So next here, I'll say with arcpy.da.search cursor, and the input here will be FC in feature class, and again shape at. It's the geometry as cursor. So I'm now now I can iterate. I'll say for row, or say for row or geom in cursor. So I'm iterating over each row, and I just want to get the geometry here, obviously. And I'm going to insert that geometry centroid in the insert cursor. So I'll say in cursor dot insert row, and then in parentheses, I'll put a list or a tuple. And here I'll say geom 0, right? Because remember, in a cursor, what's returned is a list. This list will have a single item called shape at, so the single item in the list will be a geometry. So I have to slice that with index 0 to get the actual geometry object. Then I can say centroid, because remember, that's a property of every geometry. Next, that's good. Then I'll go back out here and I'll say del in cursor, because if I do not delete the input cursor, I should say the insert cursor, all this is for nothing, because it won't commit the changes until that cursor is deleted. And I can put it else here. I'll say else print or arcpy I'll say, I could put a print here, but I'll say arcpy dot add message as such error, you must have a map open for this tool to work. So you must have a map open with layers for this tool to work. In fact, just looking at this here, I see I don't even use my layer. That doesn't need to be in there. It might be in this. It's in the slides, I think, but I don't actually do anything with it at all. So it's not really necessary to be there. But that should be cursor here. There we go. Just a couple things I noticed as I'm going through. I think I let it autocomplete there. Okay, so we do need that mapping module to make sure that a map is open. There, so I'll save this. Now I'll go back to ArcGIS Pro. And I'll say, okay, let's say input feature layer. Well, I don't have any layers in here, so let's put some layers in here from the modulate data. Maybe I'll bring in neighborhoods, for example. Then I'll run my Centroid tool on that. So I'll say double click on create Centroids from features. Choose neighborhoods. The output workspace is the default one. That's a module 8 one here. Right there. There's nothing in it so far. And then it gave a default name here, neighborhoods, Geom to Centroids, and I'll click run. And now I see over here, it's created a feature class. With a very strangely long name, but it's there. And I could bring that in and have a look at it. Let's try and drag that in. There we go. Why doesn't it want to come in? There we go, drag and drop. There we go. Now we see the centroids. So our tool created it in the workspace as it should have. And then we went to the workspace, we found it, and we bring it in. Now, most tools, you don't have to go and find the output. It will automatically add it to ArcMap if it's a visual product, right? So we want our tool to do the same. So that means we have to add one more parameter to our tool. So I'll go back to our tool here, create Centroid layer from features. I'll right click, properties. Then I go to parameters and I put a special parameter here and I'll just call it output type, feature layer. And it must be a feature layer for it to be added automatically. Type is required, but derived. So this output, this last one, which we will not see on the tool itself, is just for outputting stuff for just so that it adds it to ArcGIS Pro automatically. And then the direction, of course, is output. So derived output feature layer. And I click OK. So now there's a fourth parameter. I have to include that over here. So I go back to PyScripter. So back here, I'll hit enter after del in cursor, and I'll add this one more line. It'll say arcpy.set parameter as text. And here, the index will be the third or the fourth item that we made, the output, which was derived. And what will go there will be the new FC, like that. And this line will then ensure that our result is added to ArcGIS Pro. So I'll just save that, go back to Pro, give it a try. I'll get rid of the old, because it might just confuse you. So I'll get rid of the other one first, the dots, the centroids. So now input will be neighborhoods again. I'll just leave the name it creates and I'll click run. And it should add it right to the contents as the top layer, like you see, like any normal tool. So again, fundamentally, that's important because it makes the tool workable and enjoyable to use, or at least not frustrating to use. And again, so that's in properties, and then you define an output as a feature layer, and it must be derived. And if that's there, then in PyScripter, you set as the last thing, set parameter as text, whatever the index value of the output was, and what you want to be sent there, which is the new feature class, which was set as an output as well. We now know a little bit about making script tools, and you can see they're very easy to make. You can make script tools for any script that you want to produce. You can make it into a tool simply by paying attention to what your inputs and outputs are, and then hard coding them while you develop the script on some test data, and then changing them to get parameters as text, and then a last one to set a parameter as text if you want something to be automatically added to the map in ArcGIS Pro. Next, we're going to be working with creating a script tool and scripts with external packages. So this is something that is very common in creating applications today, because a lot of application services are actually online today. So everything's not just local. So the scripts we just made and stuff, we're just using local ArcPy functions. And anybody with ArcGIS Pro could use those scripts. And sometimes, though, there may be things ArcGIS Pro just doesn't provide. For example, calculating things like walk scores, how walkable a particular location in an urban area is. Or free geocoding services. So how to geocode something, that is, give coordinates, for example, and then from the coordinates get an address, or give an address, and from the address get coordinates. That's called geocoding. And geocoding services, there's paid ones and there's free ones. GeoPy is an interface or an API, a Python API. So a Python API, which is just an application programming interface, it's a library for Python, a library of functions that allow us to interface with more than a dozen different geocoding services, including ArcGIS online geocoding services and Google geocoding services, but also some free ones like Nominatum, which is the geocoding service provided by OpenStreetMap. WalkScore has a API that allows us to send a coordinate and address to get how walkable the area is, how bikeable it is, and stuff like that, a whole bunch of information that's derived from that. And none of that happens locally. So these are ways to interface, or we use libraries, packages to interface with these cloud-based services. So for example, web APIs, they provide immediate access to data, and this is data that would usually require complex analyses to do, which is why there's a business case for these things, like the walk score, for example. And this is from the walk score patented methodology. So in their patent application, when they put that in, they show how they calculate a walk score, basically. The idea is that you have to have data on grocery stores, drugstores, parks, schools, other types of stores and whatnot. So you have to have all that data, and then you have to calculate how far those things are from a specific location, which is right here. That's a point in space. So how far they are, and then you weight them in a certain way. And that weighting then provides a score. So there's a process or a methodology to it. And that's a complex process and methodology. To reproduce it, you have to get all that data, and then you have to do all the analysis. And so the value added in a service doing this is that people who don't have a lot of this data locally or whatever, they can still derive walk scores, walkability assessments, without having to do all the analysis and collect all the data. And so they charge for that. But they do have a free tier that allows anybody to do about 5,000 requests a day for walk scores, which is pretty good. So the API, or the cloud API or web API, whatever you want to call it, either one is the same thing, basically communicates between Python and what we call the backend or cloud service. So that hidden complexity. We don't have to deal with any of this stuff in here, all that data. All we have to do through the web API is make a request, form the request properly, and then the web API gets back the result, and then we have availability of that result in Python. So for example, let's say a walk score of 96 out of 100, 0 to 100. So we say get walk score, and we get a returned walk score without having to do all the analysis that you would regularly have to do to produce such a thing. And that's what APIs are about. And Python or high-level programming languages like Python are about, is not having to write all that base code and analytical stuff to get results. You use existing functions and methods of objects to do it instead. So the walk score API itself is from this location, and you have already installed it if you followed along with the start here part of this module. But you can go there to read more about it and learn about other functionality that it offers. Likewise, GeoPy you would have already installed by this point, and you can read the documentation at that particular location on the internet. So since we're just using limited amounts of it, right? We're not using everything in it, just to show you how this works. So one thing to use many cloud-based API services, they require that you have a key that is special and personal to just you, so that they can control access to their services, so that they can't be abused, etc. But more so that, if you go over quotas or stuff like that, then they can, call you up and sell you their service for, like, let's say you need to do geocode, tens of thousands of things every day. Well, then you would have to pay for that probably. Or if you need walk scores, for, tens of thousands of properties every day, then you would have to pay for it. And they control that through a key. So the key is the access to the web service or cloud service. So the idea is, well, if you have the key, you can open the door and get the response from whatever's inside. So the keys usually look like that. They're long character strings, and they're person to use. So you need to acquire API keys for WalkScore, for example. WalkScore requires a key. Google services also require a key. And so this these examples we'll only use the WalkScore one because the key is straightforward and doesn't require that you have a credit card to get the key. Whereas Google services, you must have a cost center and credit card in order to get a key, and you still won't be charged unless you go over $200 per month of their services. So Google gives a free $200 per month, and each service, let's say like a geocoding service, costs a certain amount, like 7 cents each or something like that. And that determines how many free ones you get a month. And if you go over that, then they charge your credit card. WalkScore doesn't do that, so it's a good example of understanding API keys and access. And it's also a way to authenticate, obviously. Again, the security of the platform is important, so only people with a key should be allowed to use it, and not anybody else that doesn't have a key, because it could be abused. So how do we get a key for WalkScore? You need to do this yourself. The first thing you need to do is create a Gmail account. You may already have one with UOttawa. You must create a different one that's not UOttawa. So we just call it a fake Gmail account. So go and create a fake Gmail account. Remember your login credentials and open up Gmail. Then you fill in what it says here on the sign up for the key. And you select first the free version right there. So you select free version, 5,000 calls per day, and provides a WalkScore for a latitude and longitude, and a transit score as well. Once you have your Google account with your fake Google name, put them in here. I'm just showing you mine, my UOttawa one, for example, as an example here. But do not use your UOttawa Gmail if you're still using UOttawa Gmail. Make sure that you do create a fake Gmail account, because it's very important. Otherwise, it won't work. So ensure you do that, a new email account. And when it asks you here, it says the address would be something at gmail.com, and then the domain must be gmail.com. So the domain must match the address domain, your email address domain. If these things don't match, you don't get a key. Do not use your UAuto email to do this. And once you sign up, basically, you'll get an email into your Gmail account with the key. And you get a message like this, and in there it'll say your API key for gmail.com, or this case is my case, UAuto, will be this. And I've just, of course, obfuscated mine so that you can't use my key. Otherwise, it would be kind of defeat the purpose of having a key. So you do that. Now, optionally, if you want to do the Google example that's in the slides here, you can go and create a project in Google Developers Console, and then enable the key, or enable the Geocoding API and get a key that way. But again, you'll need a credit card in order to set up a billing service before you can do it, and before it will work for you. So I suggest skipping the Google one unless you know a little bit about Google services. But once you do, of course, you'll get about 40,000 a month. So up to 40,000 requests a month for geocoding for free with Google before they start charging you. And that was the charging and stuff. It used to be much better previous to July 2018. So prior to July 2018, you had 40,000 a day requests for free. Then in July 2018, Google increased the cost of all their API or all their cloud-based services by 5,000% overnight. So now what you basically used to get a day, you get per month for free. So it really has decreased the amount of free use during that time. So we won't use this one, and you're not required to use the Google one. But you have to create a new project there, and this kind of walks you through it. And in the API manager, you choose whichever API, for example, the Geocoding API. You enable that, and it may look a little different. They constantly change it looks a little different even right now than it does on the slides here, but since it's not required, I didn't go through it and redo all of these ones, all this example here to show you how to do it, but it's the basic steps are the same. You enable it, and you can't use it until you create credentials and a billing the billing stuff. Once you do have it billed and everything with your credit card, you can go to the credential, create credentials, and API key you choose, and whatever you want to call that key, you get it. And then it says, here's your API key. And then you can use that for geocoding if you want to with the geocoder. Now, there are limits. So as I said, there are limits to what's free. So with WalkScore, 5,000 calls per day. With Google API, you get basically 2,500 free per day and 10 requests per second. So there's two things there in terms of throttling. So this is called throttling right here. Throttling is kind of like it comes from motorcycles, with a throttle. You rev it up and it goes faster, and as you move the throttle around, it goes fast and slow. And most API web or cloud-based services throttle anything that's free. For example, the geocoding service that we will use, Nominatum with OpenStreetMap, it's free, but they throttle it to 1 request per second. Here it's 10 requests per second. I'm not sure how the throttling for WalkScore is. I didn't see anything about that. But generally, with 2,500 per day for free, you can get up to 40,000 a month, without being charged. So we'll start here with GeoPy. So just inside of PyScripter, we import GeoPy, and then from GeoPy, we import Nominatum. That's the service we want to use. Other things are Google V3, for example. You see the example in Google Next. So you import that. Then in Nominatum, you say user agent. So you create an instance of that geocoder called Gmap first. So this is going to be an instance of the geocoder. So that's the geocoder object here. I just called it Gmap. Again, that's a variable you can call anything. Then I say Nominatum, which I imported there. And then in parentheses, user underscore agent, that's a keyword, that's a parameter, equals my app. You put a different name here. So you make your own name up as long as it's in quotes, no spaces, special characters. And that's just so it's required because OpenStreetMap requires for its geocoding client that the my app you give a name to your service or something so that it knows who you are and how many requests you're making. Now, of course, you could if you wanted faster requests, more than one per second, you could just have you could loop this and do all kinds of stuff programmatically to loop that, to change this for every request so that you could get more than one request per second. That would be called circumventing the terms of service, which is not recommended. That being said, so we have our Gmap, and then from GeoPy, we need to create a point. So I have a latitude and a longitude here. And then I create a point object, what's called a GeoPy point object, not an ArcPy point object. So I say GeoPy instead of ArcPy.point, and I put lat and long. And in ArcGIS, if it was ArcPy.point, it would be longitude, latitude. So notice how they're transposed there. So all of these services have latitude first and longitude second. So you have to remember that, because all things in ArcGIS and in GIS systems are longitude first, latitude second, because that's like X comma Y, the kind of convention. And at one time, in fact, Google had it correct with longitude first, latitude second, but a lot of people, developers, just think in terms of a lat long because you're often hearing it that way, but it's the incorrect order. So we create a point object from these coordinates right here. Then I say the Gmap object right there that I created dot reverse, called a reverse geocoding. This is where we want to get the name, an address from a point. Of course, forward, you put in an address and it gives you a lat long. So we're doing a reverse geocoding here, gmap.reverse. Then I send the point that I created right there, the GeoPy point, since this is GeoPy. And then I put timeout equals 10. So timeout just means 10 seconds. So if nothing happens for the request after 10 seconds, then just skip it and go on to the next one. Now, this reverse gives us two variables, the address and then the point, and I just have them here on the same line being assigned because that's what's returned is a list with those two things in it. And then I'm just printing them out here to show you. And when I run that, the result is this. That's the result that we get back, is the address and a point with the longitude and latitude. Now you'll notice here that the input longitude, the input latitude, I should say, right, and the output latitude are different slightly. And that's because these points are just approximate on maybe on the Tabaret Hall lawn right there. And so what has to happen in the background for any geocoder is it has to snap that to the nearest street. And so you're going to have different outputs than inputs. The outputs are the accurate street location of that particular address. Likewise, here is different. So generally, if you're doing this to create a new file, for example, of longitudes and latitudes for a set of coordinates, you want to use the return coordinates to create points, not the ones you put in, because the ones you put in aren't on the actual network necessarily for geocoding itself. So technically, with nominatum, you're allowed 1 per second. And if you need to do a few dozen, then OpenStreetMap probably doesn't care about breaches of its terms of service. There's no upper limit, I think, on the number that you can request, but it's slow. Now, if you have a few thousand to do, I wouldn't use nominatum. I'd use Google API, set it up with a credit card. And as long as you're not going over 2,500 per day, you'll be fine and you won't be charged anything. And it's much faster, 10 per second. Here's the example with Google. So if you have a Google key, then you put your Google key here. And from GeoPy, you don't import nominatum, you import Google v3. But then to initialize an instance of the Google geocoder, you say Google v3 with your API key right there. Everything else is the same. So once I do that and I put it in, I get these coming out the other end. And again, these will be different than the inputs. And they may not be the same. For example, here, if you look 454246883, and if we go back to the previous one, 4253262. So they're not the same output coordinates as input coordinates when you do this, even between different services. Why? Because different services have different networks and different algorithms for snapping, from the location you send to the nearest network edge, like right over here, or maybe it was right over here, but it was probably right there in Cumberland Street, or maybe over here, depending on where the point is. So not every service will have the same output coordinates when you send it instead of input coordinates like you see here. Google gives different than nominatum. And that's because they use completely different data sets. Now for the walk score example, we import from walk score, we import walk score API, like so. Then I have a variable for the key. So your walk score key that you got goes right there. Then I initialize the walk score API by saying walk score API, and then with the parameter API underscore key equals my key right there. And then it's ready for use. So I have an address. I have a lat long. The address is optional. You can just do it with lat long. So this is optional. You need a lat long. And this is not GeoPy, so you're not creating a point or anything with these. You're saying walk score API, or we're saying this, I suppose. The walk score API right there, dot get score. So that's the method on the walk score API to get a walk score and a transit score. And then I say latitude equals lat, longitude equals long. And you can include or not include address equals ADDR, which is the address right up here. Sometimes you get a more accurate, with the address and the coordinates, you get a more accurate output. Then that sends the request and it's stored in score. Then I can print those out. For example, print walk score, and it happens to be 91 in this case, bike score. And there's other methods on the object from the API. So the API get score object has a number of properties and methods that you can explore, like to dictionary, for example. Put the score to a dictionary. So a Python dictionary. We could put these both these things together to get the address, for example, to send. So in this case, we start with Python. So just in Python itself, so internally, we import our libraries, the walk score and nominate them. We initialize those in Python here. We take a longitude, latitude of interest, and we create a GeoPy point, which we're going to need for the nominatum up here. So that's all happening in Python. Then we make a request, for example, to nominatum, GMAP object, to reverse geocode the point with a timeout of 10. So from Python, what's happening is it's sending the request to nominatum. And then it's returned and stored here in address point, ADDR point. Likewise, we do the same with walk score. So we say WScore API, get score, latitude, lat, longitude, long, address, address. And that returns the score into score, and then we can print the stuff at the end. So let's just kind of give you an idea of what's going on there and where it goes on in the code. So Python is the you could say the central component here that we're using to gather information from these cloud services through their APIs. So let's create a tool to acquire addresses and walk scores for a point layer. So what would we envision as that tool, or how would we envision that tool being? First, well, we could create a toolbox script tool, right, that accepts a point layer, so an input point layer, or any geometry. So any geometry, any feature layer. Oops. So a point layer or any feature layer. Feature layer, of course, means vector, right? That's why this is important here. So a vector layer, any vector layer of objects. And also specify a workspace and an output for the new point layer that will contain, for each point, walk scores and potentially addresses as well. So once we define that script tool and the inputs as get parameter from text within our script, we can initialize the APIs with keys where necessary. So in our case here, we'll need a walk score key for sure, because we want to get walk scores. That's the only key we'll need. We'll use nominatum for the geocoding and reverse geocoding. Once we initialize them with keys, we can create a new point feature class that's going to hold the output points from the input layer. So we need a new feature class that'll hold the output points with their associated walk scores and addresses. Then we send each point from the input feature class. So I'll say any, let's just say geometry. So we'll send each geometry from the input feature class to nominatum to get the address. So we'll use that reverse geocoding from the point to get the nearest address. Then we send that address and X or longitude, latitude coordinates from nominatum to walk score to get a score. And then we save the walk score, the address, and the new point location from what is returned by walk score into a new shapefile. Shapefile or a new feature class. We'll use feature class in this case, so FC in a geodatabase instead of an external older format. Then we just repeat these steps 3 to 5 until all the points are processed or all the features are processed. So this is just the kind of the outline, or like a bit of almost a type of what we might call a pseudo code for what we want to do. It's mainly what we need to do. It doesn't specify here, what the commands are, what the library names are, or anything like that. It just gives us a template of what we want to do. So we can start by doing so. So I first create a tool that will be accepting these things. I start here. I call my new tool get walk score. That's the Python name. And the label will be assign walk score to geometry centroids. So this particular tool can take in any geometry set and provide or calculate their centroids, get the centroids, walk scores, addresses, and output them. I've already created a blank script file called getWalkScore.py, and I associate that with it. So again, I go to PyScripter, make a blank script, save it as getWalkScore.py, and link it here. And I keep PyScripter open, of course. Next, I specify here the parameters that I'll need. Step 2. So we said we'll need an input feature class. So that's the input feature class. Direction is input, it's required. Feature type will be a feature layer. So feature layer. Then the output workspace, where the output will be saved, and that will be a workspace. Also input. We need to give a name to the output feature class, which will be a point layer. It's also a feature layer data type required, and we have to specify that as an output. So the first two are inputs. Now we specify the third one as an output, because that's the output feature class. And then finally, output here. And this is the output that we'll use for the set parameter as text to make sure it's added to ArcGIS Pro after it runs. So output, feature layer again, and importantly here, derived. So we have required, and derived. Remember, anything with a set parameter as text to be added to Arc Pro must be a derived attribute, and the direction must be output. The last thing, of course, is for the workspace. I would scroll over to the right here under environment and choose current workspace. And then I click OK, and I have my script tool ready to go. I just have to make the script to go with it. So there it is there. So to create a tool, it's a number of steps, right? What we'll be using to do this. So creating a tool to acquire addresses and walk scores for points in ArcGIS Pro. So I start with my basic imports. Any imports I'm going to need: ArcPy, GeoPy, nominate them, and walk score API. So it's the stuff we just looked at. Then with nominate them, I give my particular user agent name so they can track me, track the requests, and I save that geocoder object in the variable gmap. Then I have a key for walk score. So I put my walk score key here, and I initialize the walk score API with my key, like so. And I store the walk score API object in wscore_API. So that's the first part of the script. Next, I'm going to create a couple functions to help me so that the script itself is smaller, and these functions go up right at the top of the script after the imports and the stuff we just had on the previous slide. So this function will be called getAddress. So obviously getAddress is going to be the reverse geocoding. It will take in Gmap as an object, GMAP has to be a nominatum reference. So it's just said in the information here. So for GMAP, for example, and then a geometry. It says point geometry, but it says it needs to be an ArcGIS point geometry. So we must send a point geometry and the nominatum reference. Now, the reason I have it here is because this tool should work on any layer. Yet for all these services, for geocoding services, they require longitudes and latitude values. But if you have a projected layer, it's not longitude, latitude. And so that's why I have a function here, because once I get the geometry, point geometry, it'll have whatever coordinate system it has, because it comes from a feature layer with its particular coordinate system, which could be, let's say, a MTM9 or a UTM zone coordinate system. But I need it to be in WGS84, because the coordinates then will be in longitude, latitude. So this is a EPSG number. And you can just Google EPSG and look at the code. This is the code for WGS84, 4326. It should be one you know off by heart, that code. So I save that spatial reference. So I'm just creating a spatial reference from ArcGIS, arcgis.spatialReference, and it creates the spatial reference for WGS84 longitude, latitude. Then I take my geometry right here, point geometry, and I say project as, so it projects it as the spatial reference right here. So project as is a method of the geometry objects. And I save that point right there in PG. So for point geometry, PG. So that PG now has longitudes and latitudes instead of whatever it came in with, which may have been X and Y. Once I have PG, then I create a GeoPy point, geopy.point, and I put my X and Y here, longitude and latitude. And I get pg.centroid.y, remember, because lat goes first, and then pg.centroid.x, which is the longitude. So GeoPy point right here now contains a GeoPy point of longitude and latitude, or latitude and longitude in that order. Then I use what's called a try except here. This is a kind of like an if then, without specifying what the if is. So basically here, what happens in a try except block is this code is tried. So GMAP, the object up here, dot reverse, we've seen before previously, the GeoPy point right there with a timeout of 10 seconds. So if that fails, so if this fails, crashes, then what happens is the address becomes timeout and the coordinates are 0, 0. And this is why I'm using a try catch, because sometimes with any type of cloud service, and there are synchronous and asynchronous ones. This particular one we're using is a synchronous one in this case. So I have to wait. It's trying to find it. If it doesn't find it, then at least I'll have something there in the address called timeout and location 00 that will tell me in my output table that that particular point could not be reverse geocoded. So I get the address and location, then I return this in a particular format. In a list, I encode the address to UTF-8. So addresses sometimes can have special characters in them and everything that can cause issues. So when I say ADDR encode, that's a encode is a method for strings in Python. And UTF-8 is just as a type of character set. It's the most common one you see, like like what you see on your keyboard, basically. So any weird characters that might be in the name of an address will be forced into UTF-8 here, re-encoded. So I give the address and then the location right here, which is, of course, either going to be 00 if it didn't happen, or it'll be a latitude and longitude. So I put that there, the latitude and the longitude. So I have a list with 3 things in it. One is a string and 2 numbers. So that's how that works. So when I call get address, I just have to send it that in a point geometry, and I get back the address and the location of that address on the network. So the function takes in the GMAP, point geometry in summary, projects the geometry into a longitude-latitude system of WGS 1984. Then it creates a point with that longitude and latitude value called GeoPy point, reverse geocodes it, and returns it the values or the result as a list every time it's called. The list contains the address and then the latitude and longitude. Then I have a second function called make feature class. The function here takes in the output feature class name, the output path or workspace, and what's called a list of fields or field list, which are the fields that I want to have in the new feature class. Then we have a spatial reference for the new feature class, which is WGS84. Because remember, the data we get returned from geocoding and from walk score is always referenced to longitude, latitude, or latitude, longitude. So we need to have a point feature class that will hold those. And it has to be then in WGS84 lat long. So once I have the spatial reference, again, I create the output feature class. But first I validate the name of the output feature class for the workspace. So that means checking that the output feature class is properly formed, because we don't know, somebody might have put spaces in the name for their output because they don't know, or stuff like that. And we know geodatabases don't allow spaces in the names of feature classes. So we have to do it that way. And then the output path. So whatever the output path is, if it's a geodatabase, it'll make the name proper for that. If it's a folder, it'll make the name proper for that, etc. Then we create the feature class. So with the output path right there, output feature class, or right here, this one goes there. Type is going to be point, and the spatial reference, that's the parameter name, is SR from right here. So we're just using, again, the create feature class tool. Now we add fields, or 4 fields in the field list up here. So for each field in that list, I use ArcPy management, the add field tool, to take this new feature class FC and add the fields to it from that field list. And in the field list is the name and the data type. We'll see that in the script portion next. And then I return the new feature class to wherever I called it from in my script. So this function then is very useful because it makes a feature class, and all I have to send in is a name of the output feature class, the path, the workspace, and the fields list that I want to have in there. And that field list should be a list with 2 things, one being a field name and this next one being a data type, like string or numeric, etc. Then I have those functions now, and I put them in my script right after whatever was previous to that. Now in my script, I have to have these things. So I have my input feature class called FCIN, and I say arcpy.getParameter is text 0. So that's that one there. Then the output path, which is the output workspace. Get parameter is text 1. Oops. Get parameter is text 1. The output workspace. And of course, then the output feature class is get parameter is text 2. And it's called FC out. So feature class in, out path, because it may, that's a workspace of some kind. Either it's a folder or for a shapefile, or it's a geodatabase for a feature class. And then the output feature class name. So that's just showing you in the script tool. We already put them there. Now, this is what we put in our script. Next, we're going to create our field list and make the feature class that will hold the output. So the field list, again, has to have, as I said, a list of lists or lists of tuples, and each tuple has the name of the field and the data type, and then comma, name of the field, data type. So I want the walk score and the address as text. Walk score is a long. So long is just a data type for integers. Then I call my makeFC function, which we saw above. I put the feature class out from the input get parameter as text, output path from input get parameter as text, and field list goes right here. And that creates the new feature class. So by having that, by putting all that feature class creation stuff in a function, it makes this part more succinct and easier to understand what's going on. So again, that's using the makeFC function. It takes the output feature class, path, and field list. Then, because the new feature class is within a feature data set, I want to get the output spatial reference. So we save that new feature class in a geodatabase. And so then I get a describe on that to get the spatial reference for that particular file, which of course we know is 4326. That's hard coded into our function. Then, so this is it, next, I should say, we create a list of fields for the insert cursor, and then we open that insert cursor on the new feature class, new FC. So the cursor fields, I have shape, and then I have this for I in field list. So that's just getting that and that as a list, and the plus sign puts those lists together. So in the final list here for the cursor fields, I have shape at, and then I have walk score and address. And I'm just notice here that I'm just doing that with a Python list comprehension. And that's just to make it succinct. I could have done or created a list with a for loop beforehand and then just added that list to shape at if I wanted to. But that's rather than retyping out walk score and address, I get them from the field list. Next, after creating a spatial reference 4326 called nominatum spatial ref, which we'll use when we create a point geometry from the latitude and longitude that are returned from the walk score call, we open a search cursor on the input feature class, and all we care about is the geometry, because remember that input feature class FCIN can be points, lines, or polygons. And we want to get the centroids of these things. Of course, the centroid of a point is just the point itself. So any of those geometries in a feature class can go into this tool. So we get the geometry as a cursor, and then we loop over each row. So I say for geom in cursor, and then geom returns, of course, a tuple. And so we have to get then right here, slice that tuple, get index 0 to get the actual geometry object. So in the second or the first line in the loop here, I get the address, the lat and long from the get address function. So remember that function that we went through? And I defined at the end of that function that it returns a list with the address and then the lat and long in that order. And so it returns 3 things in a list. And so I can assign them all in one line here. Get address, and I send the GMap reference. So that's again the instance of the nominatum to get address, which reverse geocodes it to get the address, latitude, and longitude. So that's the reverse geocode of the point. Next, with that address, the latitude and longitude, I send that to the WalkScore API. First, I check that 0 is not in there. So if either lat or long are 0, so remember the try except statement in the try and then except statement inside of ArcGIS, or inside of the get address function. That's there so that if the reverse geocoding fails, so if that fails, then the except statement gives back, a string and then 0 lat, 0 long. So I know that if this comes back with 0 here or 0 here, that the reverse geocoding didn't work. And so I can't get a walk score. So I set the walk score as 0 if that happens. In most cases, it won't be 0 because it'll work. So once it works, then I say walk score API, get score. I send the lat, the long, and the address from right here, from the reverse geocoding. And then to get the score, the walk score, I say score.walkscore. That's the property of that object, walk score, that gives us the score itself. So I have the score now. That score will be a real score, or it will be 0 if the location could not be reverse geocoded. Finally, I create a point geometry from the returned values here. So I say arcpy.point geometry, and then inside here, I need to have a point and a spatial reference. So I say arcpy.point. I take the longitude, the latitude. So notice the reverse here, order. That's really important. So that's the ArcGIS order. So when creating a point in ArcGIS, it must be longitude, latitude first, or X and Y if it's projected. Whereas all the cloud services are lat long. So it's a little thing to always remember. So I put that in there, and then I say nominatum spatial reference from up here. So WGS84, which is the same coordinate system as the new feature class that we created. Then, so that's point geom. Then I say point geom project as sref out. So sref out is the output spatial reference, which is the same as the input feature class spatial reference. So that's this way, this can be used for any type of object if we wanted it to. Then I say in cursor insert row, point geometry, score, address. So the point geometry, the score, and the address, which are the fields that we're filling up. And then it says processed that particular one. And then it repeats it for the next geometry. And so every time it does one, you can watch the messages window of the tool to see how it's progressing, because it will only do one a second. Finally, at the end, we have our cleanup. So I delete the cursors. The in cursor cursor should be deleted. It's already deleted anyway with the with statement, but just to be sure, I delete the GMap reference and the walk score reference so that they're no longer connected online. So, which would cause problems, so I would try to do it more. And then finally, the last line is the set parameter as text. The fourth parameter, remember, was just called output, and it's derived, and it's of type output, and it's going to be the new feature class that goes there. And that will then show up in ArcGIS Pro. And here's an example of it working, or of it worked. So here's the assign walk score geometry to centroids. I said neighborhoods, output workspace, gave it a name. And as it was running, I was watching the messages show up every second. And it shows the addresses being printed out and the walk scores. And then I just made a proportional circle map of the result circles to show where walk scores are higher or lower, as an example. And you should now be able to complete that example on your own.